Hi guys, welcome to the Pepcoding. Today we are going to solve this question: find first and the last position of element in sorted array. So we have an array which is sorted and we have given a target. We need to find the first index and the last index of that target in the array if it is available. If it is not there in the array, we need to return -1 and -1. There is one more thing. We have to do this in log of n times. So let's see. Let's say we have a sorted array. Now we want to find element 2 in this array. So here this is the last index, this is the first index. Now what will be the first index of the 2? Here the first index is 2, the last index is 6. So we need to find these index and return it. And now we have to do this in log of n also. We can do this in O of n. How? We can start traversing from starting point. When we get the element, we will save the first index is equal to the 2, that is the first index. We will start a second loop from the last. When we get the element, we will update the last index as 6, but it is in O of n and we want it in log of n. So how will we do this? We have a sorted array. Can we use this? So in a sorted array, when we need to find an element in log of n times, we can use binary search. So exactly what we are going to do is we will use binary search to find first index and the last index of the element. Now for binary search, first there is a low, then high. This is the first index, this is the last index, and sliced by -1 and -1. Now for finding the first index, first find the mid. What is the mid? 0 plus 9 by 2, that is 4. 4 is the mid. Here at the mid we get the target value. So we will update the first index by 2, that we have the target value at mid. Now if we find the element, the high will be go from here to mid -1. So mid was here, high is gone to here, low will be at 0. Now again, why we are moving our high to left side? Because we need the first index. So first index will be in the left side of the array if we find the data, because it is sorted. So this property of sorting we can use to find the data. So high is at mid -1. Now again find the mid. Mid will be 0 plus 3 by 2, that is 1. Now at 1, the element is smaller than 2. 1 is smaller than 2. So what we need to do is we will move our low to mid plus 1. This was mid. Now low is here. Again check for the mid. Mid will be 1 plus 2 divided by 2. Sorry, low is at 2. So 2 plus 3 divided by 2. This is 2. So mid is 2. We will check array at 2 is equal to target. Here target is 2, it is equal. So we will update the value. Again the updated value will be here. This was first we get the value at 4, so it was updated by 4. Now it will update it by 2. Now it is updated by 2. High will move from here to mid -1, that is here. So the condition is low is less than or equal to high. Here high is less than low. So loop will break and we get the first index is 2. Now for right index. For right index we are going to do binary search for right. Now low will be here, high will be here. Check the mid. Mid will be 0 plus 9 by 2, that is 4. This is the mid. At mid we get the target value, so we will update the last index. This will be 4. That is we have get the at least the index where the value found. Now we are getting the value, target value at 4. The low will be moved to mid plus 1. Why? We want the last index. So for last index, if we find the data, we need to move to the right side because it is sorted. So the last index will be in the right side of the array. Now again find the mid. Mid is 5 plus 9 by 2, that is 7. Now 7 is the mid. Array at 7 is 3, that is greater than target, that is 2. So high will be moved from here to mid minus 1. So high will be here from there to here. This was low. Again find the mid. Mid is 5 plus 6 divided by 2, that is 5. Now mid is 5. Array at 5 is equal to the target, that is 2. So we will update the last index as 5 and move the low to mid plus 1, and mid was 5, low will go to 6. So this will be at here. Again find the mid. Mid is 6 plus 6, high was at 6, low is 6, divided by 2, that is mid is also 6. Now array at 6 have also the target, that is 2. Again update the value. Move the low to mid plus 1. So mid was also 6, so low will be at 7. Here the condition will false because high is less than low, so low will break. So by doing this we get the last and the first index of the target value in log of n time. We have just did 2 binary search, one for the left, one for the left for the first index, one for the right for the last index. So what will be the condition? If array at mid is equal to the target, this means we need to update, this is for the first index, we need to update our answer at 0. 0 will save the first index, is equal to mid, and we want the first index, so high will go to mid minus 1. This will be mid minus. Else we will check array at mid is smaller than target. This means low will be mid plus 1. Else high will be mid minus 1. This means target is smaller than the array at mid. So we will move our high to mid minus 1. So this is the pseudo code. Let's code this. Now what we have is, we have the array of n elements, we have a target, we have an answer where the size is 2 in slash by minus 1. We need to write the solution. Now solution, first we will right for left binary search for finding first index. Now we need the low, which will be at 0. We need the high, this will be array dot size -1. Now find the search, low is less than equal to high. Find the mid will be low plus high divided by 2. Now check the condition. If array at mid is equal to the target, if it is equal, we will update the answer at 0, which is saving the first index as mid, and update our high as mid -1. Else, if array at mid is smaller than target, this means low will be at mid +1. Else, this means target is smaller than mid, so high will be mid -1. So this is the binary search for finding first index. Same as for the right, we need to update our low and high again. Array dot size -1. Same binary search for right. This is for right binary search for last index, for finding the last index. So last index is saving at answer at 1. We have the size of the answer 2. So at 0 it is saving first index, at 1 it is saving last index. Here when we find the target, we need to go to low will go to mid +1, because we want the last index. So this is the change for left binary search and the right binary search. Let's run this. So let's submit this. It is accepting all the test cases. Hope you understand this concept. Please like the video, share the video and subscribe the channel.